Hello and welcome. So we are going to be drawing the shear force and the bend moment diagram for this above question. So for us to do this, we are going to be going straight to calculate our shear force calculation, because you know that this is a cantilever beam. It is fixed at one end. So let's go with shear force calculation. All right. So we are going to be starting with the shear force at A. So shear force at point A. All right. So if we start at point A, we are going to look to our what? Our left. So if you look at your left, we don't have any force. So it means that the shear force and at point A is what? 0. Now let's look at shear force at point B. The shear force at point B. If you look at point B here, we have a uniform distributed load from this point here to this point. So which is going to be what? Which is going to be, you are going to convert it to a point load. That is 2 multiplied by 2. That is what? 4. Is that clear? And don't forget, this is a downward force. So here we are using upward force, positive, and downward force, negative. So it's going to be what? -4. So -4 kilonewton. All right. So last but not the least is the shear force at point C. All right. So if you start at point C here, we are going to have -4. Then now again, that is the shear force around this point. That is the shear force at point B rather. So now if you look at this point now, if you try to complete this line, you are going to have another uniform distributed load from point B to what? To point C. And then we are going to have a uniform bearing load. Alright, so if we convert this uniform distributed load to a point load, don't forget it is 2, right? So it's going to be 2 times 3, 6. So this is going to be -6. Alright, so here we have from this point to this point to be 4, and from this point to this point is 2. So 4 minus 2 is 2. So it means that the length of this plate is 2. So converting this triangular load to a point load, we are going to have it to be what? Half multiplied by, that is -half, multiplied by the base, which is 3, times the height, which is 2. So this 2 will go with this 2. So this is going to be equals to what? -13. All right. So we are done with the shear force calculation. So let's go for the bending moment calculation. All right. So we are going to start at point A again. The bending moment at point A is of course 0 because we don't have any force there. So the bending moment at point B now. Bending moment at point B. All right. So if we start at point B, if you want to take your force, we know we have a uniform distributed load here. So if you convert that to a point load, it's going to be what? 4, right? So 4 multiplied, and it's going to act at what? 1 meter to the right and 1 meter to the left. So if you want to take your moment, it's going to be -4 multiplied by what? By 1. Is that clear? So -4 multiplied by 1. All right. So that is the moment that we are going to have there, which is going to be what? -4 kilonewton meter. All right. So we start at point C now. Bending moment at point C will be equals to, so our bending moment at point C, if we start at point C, you convert this to a uniform distributed point load, I'm going to have -4. And -4 is going to act at 1 meter here, 1 meter here to point B. So the total distance is going to be 1 plus 3, which is what? 4. So we are going to have -4 multiplied by what? 4. All right. So don't forget, we also have another uniform distributed load here, which is 2. 2 times 3 is 6. So -2 multiplied by what? 3. All right. So that is the distance. Okay, let's just take it as 6. So we can multiply by the distance. That is -6. Then the distance is going to be multiplied by 3 divided by what? 2. So multiply by 3 divided by 2. All right. So we have another uniform distributed load here. When we convert it to a point load, we have it to be what? We have it to be 3, right? So, and it's acting downward. So it's going to be -3 multiplied by 3 divided by 3. right? So now, the next thing we are going to have here, this is going to be equals to minus 4 times 4 is 16. This here, 2 here 1, 2 here is 3. So minus 16 minus 9, this 3 will go with this 3. Minus 16 minus 9 and then minus 3. Minus 9 minus 3. Everything is going to give us minus 28 kilonewton meter. All right. So that's what we are going to have now. So the next, I draw the shear force diagram, the bend moment diagram. Every point that we have low, we are going to draw it downwards. All right. So we are going to draw our shear force diagram now. So the shear force at point A is 0. The shear force at point B is minus 4. And the shear force at point C is negative 13. All right. So here we are going to have an inclined line here. So right here we are going to have a curve. We are going to have a curve. All right. So let's go for the bending moment. All right. All right. So for the bend moment at A is 0. Bend moment at B is minus 4. And the bend moment at C is minus 28. All right. So here we are going to have a curve all through. Right. Don't know. It's going to go like this. Let's just do it one after the other. All right. So now this is a curve. It's not a straight line. All right. All right. So this is negative. Right. This is negative as well. All right. So this is how to go about the solution of this question. Thanks.